Hello everybody, so what I want to do in this video is I first want to or actually give me 1 second. So I first want to go over, I did want to go over linear functions, how to graph a linear function, but instead what I want to do is for those of you that are barely starting college algebra, I want to state what a linear function, or actually, so I first want to state what a function is. So the one of the questions that you kind of like one of the first things you learn in algebra is what is a function, right? So and a function is usually it's usually think of it like a machine. So you have an x, and then you input it to some machine, and it gives out a y term, right? That is what a function is, and in the machine there can be any kind of equation. So usually, so for example, I'm gonna just state a few kind of functions that that like in terms of x and y. So y equals 2x. This is a function because what we can do is we can put anything for x and get out a y. So if we plug in x equals 1, we get y is equal to 2 times 1, which is 2, right? So that is a function. Another way to know what a function is something that is called the vertical line test. So anytime you have any kind of curve, so for example, let's say we have this curve here, and there's something called a vertical line test where you draw vertical lines on the graph, and you see that you have to test whether they only cross, how many times they cross the graph. So here we can see that in these specific points here, they only cross once, right? So we can tell that yes, this graph is a function. Now, if our graph is something like this, so let's just say that we have a graph that looks something like this. Now, here's where the vertical line test fails, right? Now, let me write a vertical line test. So, graphically, if we do the vertical line test, we see that it crosses 2 times. So it crosses once here and then another time here, which means that we have 2 y's for 1 x, and you're kind of wondering, well, how would that be a thing? We can't make up an equation an equation where like if we say y equals, in terms of y equals, we can't make up an equation that has something like that. So then this would not be a function. So yes, this would not be a function because you see it crosses 2 times here on the graph, and it goes throughout all the graph, right? You can't have something like that. Even if we had something like this, where like it doesn't even have to be a circle, it can be something like this where we have like this, for example. We can't we cannot have, this is not a function because it crosses two times, one time here, one time here, one time here, one time here, and etc., right? So this can't be a function, but you know, but this is a function because it only crosses once. That is one of the first things that you learn in college algebra. Now, in terms of a table, let's say that we have a table. Let's say we have 1, 3, 2, 6, 3, 5, 4, 1, and 5, 3. Or 5, I'll say 5, 4. So here, if there are no repeating x's, so no, if there are no repeating x values, then the table represents a function, okay? So like, basically this is what a function is because it has one x for every y, so only one x represents every single y term. And there are no, like, you know, so now if we have something like this where we say one, 3, 2, so 1, 3, and then 2, 3, and then 2, 5, and then 3, 2, 4, 6, and then 5, -1. So here's where the problem, here's the problem. We have a 2 here and a 2 here. So like, if we actually plot this on a graph, so like if we, so let me go on Desmos really quick, just so you guys can understand how this looks. And this might be reviewed to some of y'all because obviously I'm pretty sure that if you did take intermediate algebra or beginning algebra, you may have studied this. So let's go ahead and just plot the points, right? So 1, 3, and then 2, 3, and then 2, 5, and then 3, 2, and then 4, 6, and then 5, -1. So you see here, there's a problem. So there's a problem here and here. When you do the vertical line test, you see that from here, so from here to here, it crosses twice. So that means that this is not a function because you cannot have, how would you represent in terms of x and y, you know, like in terms of f of x equals, and you know, I mean, you can do it with a piecewise function, but that's something that we haven't, I don't think that they've, you know, we don't know what that is yet. Piecewise functions are another thing, but we can't, in terms of x and y, if we just say in terms of y equals mx plus b, or, just y equals literally one equation, we cannot represent this as a function, okay? Now, what about, so that's how, basically, you cannot have any repeating x's, it's the point. So this is not a function. Okay. And so basically a function, as long as you see the vertical line test cross only once, that is how you will know that it is a function. Okay. Give me 1 second. Now, in a function, there is also what is called the domain and range. Okay. The domain is x, so like the x values. And the range is all y values. So if they want you to, and there's also something called set builder notation. I think that's what it's called. Give me 1 second, guys. So set builder notation. Give me 1 second. So set builder notation usually is, actually, just the word set itself, you can represent. So for example, I have 2, 3, 4, 6, 3, 9, or let me do 5, 9, and 6, 2. Okay. If I want to represent a set, like the set of all numbers in this table, I can say, okay, do a little brace. This is called a brace. Okay, so you're going to do like a little brace like this, and you're going to say that the domain is the following. And you may have done this in high school, or maybe if you've taken beginning algebra, intermediate algebra, this should be familiar to you. So you would have the domain as 2, 4, 5, 6, and then the range would be all these numbers here. So like the range, this is the range, right? So the range is, oops, 3, let me actually make this 12. 3, 6, 9, 12. And it doesn't have to be like it can be any numbers really, as long as it doesn't repeat, or like as long as like in the domain it doesn't repeat, there's no number repeating, then it can be a function, right? And that is what we went over earlier, that as long as there are no repeating x's on the table, then it can be a function. So that is basically what a set is. Now, set builder notation is something different, and I'm not going to go over that in this video, only because it's just something that, is covered later on. But that is what a set is. And usually when you have x and y, you can state basically what I'm saying is that in terms of domain and range, if you have, for example, 2, 1, 0, -1, -2, and then you just have like 3, 4, 7, 6, 9, it is okay for, so basically you have one going here. Let's say you also have one going this way, or actually, it's okay for you to have something like this, basically. Now, let's say that we have 2, 1, 0, -1, -2. And then we also have 3, -1, 7, and then 6, right? Just those two. It's okay for you to have something like this. So like, basically what I'm saying is that you can have something like this, but also where another number also is the same exact thing. So like, for example, you can have 2, 3, 2, 3, 1, -1, 0, 7, -1, 6, and -2, 6, right? So it's okay for you to have something like that. And if we actually plot those on the on Desmos, it will represent a function. So give me 1 second, just so I can make sure I actually plot these correctly. Hold on, guys. Give me 1 second. Okay, so having something like this is okay because you see, if it does follow the vertical line test, and there are no repeating x value, or like, what I'm saying is, for every x value, there is only one y value. So if you have an x value that has two y values, then it wouldn't be a function. So like, if I literally went ahead and added, give me 1 second. If I literally went ahead and added -2, 7, then you see here, because of this, then it wouldn't be a function. Versus if I just had something like this, right? You cannot have vertical, like, what I'm saying is you cannot have any vertical lines on your graph, because then it wouldn't be a function. Also, you can't have, because like, what I'm saying is it has to follow the vertical line test. So this does follow the vertical line test. So it would be considered a function, right? And we don't have to know what kind of function it would be, as long as we understand that yes, it's a function, because there's only one y value for every x value. Sorry guys, give me 1 second. So yeah, so as you can see, this is a function, right? And now there is something called function notation. So when we have a function, there's something called function notation, and let me go ahead and I feel like the book explains it a lot better. So function notation here says, okay, so it says y equals, so the notation y equals f of x defines a function named f. This is read as y is a function of x. The letter x represents the input value or independent variable. That's another thing I wanted to go over. The domain, which we know as x, can be also defined as the independent variable, x. So x is always your independent variable. Okay. Y is known as your dependent variable, or also your range, right? So that's another thing that I want to clarify about this. So for example, so usually when they, in application problems, if they have an input that, let's say my input is the number of months, right? So the way that they would denote that is they would say, well, the output, which is whatever output that they give them, would be, and f is the rule, because it's, it's a function, so there has to be a rule, right? So, and then the input would be the number of months. So let's say, so right here, so it says use a function notation to represent a function whose input is the name of a month and output is the number of days. So for example, if I say the name of the month, which is January, and the output is how many days are in that specific month, we know that the number of days in January is 31. So the input would be the name of the month. The input is the name of the month, and the rule is f. So that means that f of m would be the number of days. And like I said, it depends on what the input and output is. If the input starts with a specific letter, then you're going to use that letter for your input. So like f of m equals d. That would be d equals f of m. And that is how we do it for application problems when we are given real-world problems. And that is why when you do application problems in algebra, you see that it is not, like, whenever they give you functions, they don't usually do, or they might even use like p of m or something like that, depending on, if there's a specific kind of like rule that they want you to find, depending on the function. That's a little more complicated to explain, so I'm not going to really go over that, but as of right now, but that's just how it is. So let's see. So here's another thing, and I believe that for functions we have to know, how to evaluate functions, and I believe that this is the last thing I'm going to go over, because I don't want to overwhelm anybody. I will go over, like, what is it called, like the just evaluating linear functions. I don't want to do because I believe that evaluating functions is another section that because yes, this is about functions and function notation, and this is what I was talking about with when it's not a function versus when it is a function. Actually, I'll go ahead and do it, because why not? So usually the types of functions that we study in algebra, there's a constant function where a function represents a specific number. So like if we say f of x equals 1 or f of x equals 2, for example, it would be 1, 2, so it'd be this one here. But c is just any number here. So like if I show you guys with Desmos how it looks, if I put f of x equals c, you see how like it's literally just a number on the y-axis, okay? That's literally what it is. So if I put f of x equals x, this is the linear function, right? But like I said, these are just the kind of functions. The kind of functions that we will study in algebra, these are just some of them. So like the constant function, f of x equals a certain number. The identity function, f of x equals x. So like for for every single function that we study, so like cubic functions, quadratic functions, absolute value functions, logarithmic functions, exponential functions, quartic functions, polynomial functions, rational functions, radical functions, etc. All of those are always going to have like the parent function. So when they talk about the identity function, they mean the parent function, and the parent function is always x. So like just to quickly, I'm not going to really go over this but like in depth, but I want to just say f of x, there's f of x equals x, f of x equals x squared, f of x equals x to the n, such that n is greater than 0, greater than or equal to 0. Or actually greater than 0, because, well, yeah. Also, there's f of x equals square root of x, f of x equals log of x, f of x equals a to the x, such that a is any real number. And then, what else? That you can also have f of x equals ab to the x, such that a does not equal 0, and b does not equal 0. What else? There's another one. Oh yeah, and then there's f of x equals ax plus b over cx plus d. This is rational function. So we will go more over those in the future, but if you want to look at my old videos about those, you can. But this is mostly for those that like are going back to school, that you're kind of barely new to this, or you're reviewing. And a relation is just a kind of relationship between x and y. There's a difference between a relation and a function. A relation is like, for example, number 10, this one here, so this one right here is a relation. But is it a function? Well, if we go ahead and graph this, if we go ahead and go on Desmos and graph this, if I put x equals y squared, you can clearly see that it does not follow the vertical line test. So this is not a function. Okay, so you have to be very careful with how it looks. Usually when y is either squared or cubed, or if there's a square root on y, or even if you have x in terms of x equals, usually most of the time it is not a function, unless you can literally solve for y in where it does not give you plus or minus, then it will be a function. Like, basically if it does not give you plus or minus, then it is a function. So usually, like number 40, we went over this earlier. This one is a function. Number 40 is a function because it does follow the vertical line test. It only crosses the vertical line only crosses once, so it is a function. But what about number 41? Number 41 You see how it crosses twice? Like there's 2 points in where it crosses when you do the vertical line test. So clearly this is not a function. And what about number 44? You see how it's a circle, so if it's a circle and it crosses it, so it crosses it right here and right here, right? So it is not a function. So you just have to know the rules, and as long as like it only crosses it once for the vertical line test, then yes, it is a function, right? And like I said, for this one, for number 60, if determine whether the relation represents a function. If there are no repeating x's, so like basically these numbers here, we should all know at this point the form of a coordinate point, x comma y. As long as the x part is not repeating, then it is a function. Now, this is evaluating functions. I'm gonna do, so I will go ahead and do this only because, you know, just so you guys understand what I mean when you put, how a function works, when you put an input and you get a specific output. So I'm gonna do numbers 68 through, I'll do numbers 68 through 75, okay? So this one, number 68 says, so it says, they want you to find f of -2, f of -1, f of 0, and f of 1, and f of 2. So basically, let's just do number 68. And number 68 says f of x equals 4 minus 2x. And they want you to find f of -2, f of -1, f of 0, f of 1, and f of 2. So if we go ahead and do f of -2, so f of -2 can be denoted as 4 minus 2 times the quantity -2. And like I said, guys, you have to know how to do order of operations. Usually, when we say 2 times 3, this can be rewritten as 2 parentheses 3, because the parentheses tells you that they're being multiplied, which is 6, right? So like, if I go on Desmos, and this is just review for those of you that kind of don't understand how parentheses work, 2 times 3 is 6. 2 times 3, 2 parentheses 3 is 6. So you see how it's the same exact thing. In algebra, I'm going to say this, in algebra, you are going to use parentheses for multiplying. You will not use the little dot for multiplying, because there's a reason for that. That is because anytime you're evaluating a function, you have to put parentheses for the x, okay? You're not going to put, I mean, you can put the number, but honestly, if I say like, let's say I say, for example, let's say this function was 4 minus 2x squared. Let's say f of x, right? And it wants me to do f of -2. Basically, what I'm saying here is 4 minus 2 times -2 squared is not equal to 4 minus 2 times -2 squared, unless I literally say 4 minus 2 times -2 squared. Then yes, this is equal to 4 minus 2 times -2 squared. But usually, you wouldn't put the dot here. You can take the dot off. So you can just say it like this, okay? So the little dot to represent multiplication, you're not really going to be using that in algebra. Like, you can, but it's going to look, I mean, a lot of professors, I would say, they don't really use it in algebra because it is rarely used anymore. Like, when it comes to, the only time you will ever use the little dot again is when you do, when you go to pre-calculus and you do, like, dot product with vectors, and that's a whole other thing. But dot product is something so different. So it's not even dot product, like the dot that you use when you say 2 times 3 versus something like this. You know? It's really different, and you will learn those when in due time, but I don't want to go over that because obviously we're not doing vectors, we're doing algebra, so just make sure, the point is that just make sure you use parentheses when you are evaluating, when you're evaluating expressions. So to finish this off, we have f of negative 2, we have 4 minus 2 times negative 2, so it's going to be 4, and then minus, and then we can say, what is 2 times negative 2? That's negative 4. So then we use this rule, a minus negative b equals a plus b, right? A negative of a negative, right? The negatives cancel out, so you're going to say plus 4. That's 8, right? Okay, so let's do number 69. 8, or actually, let's do f of negative 1. F of negative 1, and again, I'm going to use the same exact thing. I'm going to do the same exact thing that I was doing. F of negative 1 is going to be 4 minus 2 times negative 1. This is really 4 minus negative 2, which is 4 plus 2, which is 6. You can do it another way. You can literally say, if you really understand that a negative times a negative is positive, you could just say 4 plus 2. You don't even have to do 4 minus negative 2. You can just do 4 plus 2, and then there would be 6, right? F of 0. Now, I know that, like, sometimes it's good to just, even though if you really understand quadratics, and if you understand polynomials and how they work, basically, it's always good to just evaluate. So, if I do f of 0, I get 4, and then I get minus 2 times 0, right? So then I have 4 minus, and then 2 times 0 is 0, so then I have 4. So f of 0 is 4. And then f of 1, so if I do f of 1, if I have, so again, it's 4 minus 2x, right? So then I have, f of 1 is going to be 4 minus 2 times 1, which is 4 minus 2, which is 2, right? So f of 1 is 2. And now f of 2, which is the last one, I'm going to do f of 2. And again, f of x is 4 minus 2x. So f of 2 is going to be 4 minus 2 times 2, which is 4 minus 4, which is 0. So f of 2 equals 0, right? You always want to make sure that you put it f of 0 equals, f of 1 equals, f of negative 1 equals, etc., so that way your professor knows, or your teacher knows, that yes, you're doing it the way that, that they want you to write it. You don't want to just say, oh, it's 8. They're going to be like, well, what is 8? I mean, it depends on how strict your professor is. Some professors, like, they accept it this way. Other professors, they literally want you to write it in this form, like f of something equals something. And it just really depends on your professor, guys. I'm sorry. I know some professors are, they're very strict. So honestly, I have no control over that. I'm only here to tutor, to help you guys succeed. So let's look at the next one, number 69. So number 69, it's kind of similar to what we were already doing. So I'm going to go ahead and skip that one, because it's a linear function. Now, what about number 70? Number 70, now if anybody has any questions about the linear one, you can let me know and I can do another example on my shorts section. But yeah, the linear ones are probably the easiest ones. Okay. So number 70 is 8x squared minus 7x plus 3. So we're going to go ahead and do that. And we want to do so again, we're going to do f of negative 2, f of negative 1, f of 0, f of 1, and f of 2, right? So we have f of negative 2, so we're going to do f of negative 2. And again, you're going to use parentheses. So for every single part, and if you guys want, I can go ahead and write it this way, f of x. So f of x equals 8x squared minus 7x plus 3, right? I can plug in negative 2 for x, right? So I have 8 times negative 2 squared minus 7 times negative 2 plus 3, right? Let me move this a little bit. Alright guys, give me 1 second. I need to make sure I move this correctly because I don't want to. F and f of x, right? So then, like I said, yes, that's how I'm doing it. And that's how you're going to be doing it in algebra, right? So you have 8, and then negative 2 quantity squared is 4. And then minus 7 times negative 2. So we have, that a negative times a negative is a positive. So you know that negative a times negative b is ab, right? That is if I have literally, negative a times negative b, like this, is equal to ab, right? So you're going to do plus 14 plus 3. And then you have 8 times 4, that's 32, plus 14 plus 3. And then this is going to be 46 plus 3, so that's going to be 49. So we know that f of negative 2 equals 49. Now, what about f of negative 1? F of negative 1, you're going to do the same exact thing. Is equal to 8 times negative 1 squared minus 7 times negative 1 plus 3. So you're going to do, so like I said, if it has a parentheses on it, remember what I said, negative 1 squared is equal to negative 1, but negative 1 quantity squared, parentheses squared, equals 1. So you're going to have 8 times 1 And then negative 7 times negative 1 is positive 7. And then plus 3. So then you just multiply across. So go from left to right. 8 plus 7 plus 3. This is 15 plus 3, and that is 18, right? And what about f of 0? So f of 0, and again, if you really know how how quadratics work, and you know like that every x is just going to be a 0, and you're going to end up with whatever's on the end of your quadratic, then that is great. If you know how to do it that way, I salute you. That is great, because that saves you a lot of time. But for some of us who are barely starting, or who don't remember a lot of algebra, we want to make sure that we do it the way that we've always been taught. So have 8 times 0 squared, and then minus 7 times 0 plus 3. So then we have 8 times 0 squared, that's 8 times 0. And then we have 7 times 0, that's just going to be 0. And then plus 3, right? So then we have 0, 8 times 0 is 0. And then minus 0 plus 3. So then 0 minus 0 is 0. And then 0 plus 3, that's just going to be 3. Okay. And for those of you wondering what I was talking about when I said that anytime you plug in 0 for x on a polynomial, you will always end up with the last term. That is true. But sometimes your professors or your teachers want you to show the work. So that's why it's important to show the work. Like if I literally just said that f of 0 is 3, they're going to be like, well, how do you know it's 3? You need to show the work. And I know that some of us are like, well, why should I show the work? Like it's kind of stupid to show the work if the professor knows that obviously it's 3. But some professors, like I said, in college and in school, they really want you to show the work, and that's why it's very, very important. And I know it sucks, but it's just how it is. So we have f of 0 equals 3, and then, let's see. And then we're going to do f of 1. So f of 1 is going to be 8 times, so again, if you're wondering what the function is, let me write it again. F of x equals 8x squared minus 7x plus 3, and we're just plugging 1 in for x. So we have 8 times 1 squared minus 7 times 1 plus 3. So then that's going to give me 8 times 1 minus 7 plus 3. So then I have 8, and then minus 7 plus 3. So 8 minus 7 is 1, and then plus 3 is 4. So then I have f of 1 equals 4, right? And now let's do f of 2. So f of 2, it's going to be 8 times 2 squared minus 7 times 2 plus 3, right? So I have 8 times 4. So it's going to be 8 times 2 squared, that's 8. You're going to do the 2 squared first, that's going to be 8 times 4. And then 7 times 2, that's 14. So it's going to be minus 14 plus 3. So then 8 times 4, that's going to be 32. And then minus 14 plus 3. You can do, so if you want to do it by hand, you can. If you have a calculator, that's good. Sometimes, though, they don't let you use calculators for this part. It just depends on your professor. It really does. Like I said, every professor is different. I don't know. I'm just showing you guys how to do this by hand, really. So 18 plus 3. You have 32 minus 14, that's 18. And then plus 3, that's going to be 21. So f of 2 equals 21. Okay, and that is how you do, that is how you do number 70. I'm gonna like move forward just a little bit, only because, you know, I don't want to, like I said, I don't want to spend too much time doing all of these different ones. I'm gonna do a negative number and a positive number for every single one. Only because, like I said, I don't want to, I really don't, like, I don't want to make this video too long. So number 71, I'm just gonna do, I'm gonna do f of negative 1, f of 0, and f of 1. That's the only thing I'm gonna do. So number 71, I have f of x equals, it's gonna be, so I have 3 plus the square root of x plus 3. Now, do not get, do not worry about what kind of function this is. You know, we're just evaluating. We're just plugging in a number for x, and we are seeing what that equals. We're not trying to figure out, oh, is this a quadratic? Is this a radical? Is this a rational? It doesn't matter. That's not what it's asking. It literally just wants you to evaluate the function. So we're going to do f of negative 1. And let me actually... And by the way, so when we do f of negative 1 for this one, it's going to give you a square root that you can't really simplify very easily, because obviously, so if I do 3 plus the square root of negative 1 plus 3, so if I do negative 1 like this is going to give me 3 plus the square root of 2, and you can just leave it like this. So f of negative 1, that is if they don't give you a calculator. I mean, if they don't want you to round it, and they just want you to leave it like that, then just go ahead and put 3 plus the square root of 2. It really depends, because some professors will say, well, round to the nearest tenth, or round to the nearest hundredth, round to the nearest thousandth. Like I said, it depends on your professor. You know, rounding is really one of those things that by this point you should know how to do. I'm sure they go over it in beginning, like when you do beginning algebra or intermediate algebra. But yes, that's just, you know, most of the time there are professors, even when you do certain equations like exponential equations or logarithmic equations, you're gonna have to do, like, some professors accept the unrounded answer, but other professors are going to be like, well, you're going to have to round it. For example, if I have ln of 6 minus ln of 5 all over ln of 3, natural log, and they're going to tell me round to the nearest thousandth or round to the nearest hundredth. It just depends. Like I said, I don't know what your professor is saying. I don't know how your professor wants it. If anybody wants me to do a video on how to round the answer, please let me know. Like, if you're wondering about a specific problem or a specific topic that you're struggling on, and where you're saying, well, I don't know how to round it whenever we do logarithmic function or logarithmic equations, then let me know, and I can post a video about that. But as of right now, I'm just going to leave it like this. Number 72. We have f of x equals x minus 2 over x plus 3, right? So, I'm gonna do, oh, and by the way, let me do f of 0 for this one. Let me do f of 0, and then I'll do f of 1. So f of 0 is 3 plus the square root, and it's going to be 0 plus 3, right? So we have 3 plus the square root of 3. We can do f of 0 equals 3 plus the square root of 3, so in this form too, right? And then we're going to do f of 1. So f of 1, let's do f of 1. So f of 1 is going to be the following. 3 plus the square root. We're going to do parentheses, and we're going to put a 1 for x plus 3. So because it's positive, we don't have to include plus or minus because it is positive. We know it's positive. We're adding. We're not subtracting, okay? So we have 3 plus the square root of 1 plus 3. This is 3 plus the square root, and then we have 1 plus 3, that's going to be 4. So then what is the square root of 4? We know that's 2, right? Because remember, the square root of a, hold on, so basically, you should know this rule here. You know, so if you don't know how to do square roots, this is the rule here. So that's a whole other thing. I'm not going to really go over it, but we should know that the square root of 4 is 2. We should know our common square roots, like the square root of 9, the square root of 4, the square root of 16, the square root of 25, etc., and the square root of 100. So on and so forth. So yes, you should know how to like for radicals, how to simplify radicals. So we have f of 1 is going to be equal to 5 here, right? Okay, so number 72, I'm going to do f of negative 1, f of 0, and f of 1. So f of negative 1, we have negative 1 minus 2 over, and it's going to be negative 1 plus 3. So negative 1 minus 2, that's negative 3. And then negative 1 plus 3, that's just 2. So we know that f of negative 1 equals negative 3 halves. What about f of 0? So f of 0 equals 0 minus 2 over 0 plus 3. So 0 minus 2, that should be negative 2, and 0 plus 3 is just 3. So f of 0 equals negative 2/3. And what about f of 1? F of 1, so f of 1 is equal to 1 minus 2 over 1 plus 3. So 1 minus 2, that's negative 1, and then 1 plus 3 is 4. So f of 1 equals negative 1/4. Okay? All right, let's go on to number 73. Number 73 says 3 to the x, okay? So 3 to the x, this is, we're going to do f of negative 1, f of 0, and f of 1. So f of x equals 3 to the x. So, so basically, for this one, we have, so if I do f of negative 1, oops, if I do f of negative 1, let me just make sure that, okay. I do f of negative 1, I have f of negative 1 equals 3, and then it's going to be to the negative 1 power. Now, one of the things that you should know at this point is that anytime you have a to the negative n, this should be equal to 1 over a raised to the nth power. So if I have, this is simple arithmetic. If I have 3 to the negative 3, this should be 1 over 3 cubed. If I have 3 to the negative 2, this should be 1 over 3 squared. If I have, and then if I have 4 to the negative 5, this should be 1 over 4 to the 5th. You're just putting, you're putting a 1 on top of the, like, you're making it 1 over, and then you're going to put 4, and then you're going to put whatever it is they gave you, but you're going to put the exponent as a positive. That is how it works. Okay. So this ends up being 1 over 3 to the first power, and this is just 1 over 3. So f of negative 1 equals 1 over 3. Okay. F of 0, if I do f of 0, and I know that f of x equals 3 to the x, I'm going to say f of 0 is 3, and I'm going to put raised to the 0 power. Now, one of the things that you have to remember is that any number to the 0 power is equal to 1, such that a is any real number. Okay. So that means that 3 to the 0 is just going to be 1. So that means that f of 0 is going to be 1. Okay. Now f of 1. So again, f of x equals 3 to the x. And if I do f of 1, it's going to be 3 raised to the first power. So it's going to be 3, right? And then that is what f of 1 is going to be. F of 1 is going to be 3. Okay. Okay, let's go on to the next one. So, oops. Okay, so number 74. Okay, so let me see, give me 1 second. Okay, so I'm gonna go ahead and I'm gonna finish the rest of this. Like, I'm gonna do number 74. Which other one? Number 74. Hold on. Give me 1 second, guys. Hold on. Because I'm not gonna do equations yet, only because that's just a whole other thing. I'm gonna finish this off with, what is it called? Hold on. So we already went over functions, and then there's, hold on. Give me 1 second. Okay, so I'm gonna let me just finish off evaluating functions. Like, basically what I went over in this video, I just went over what exactly a function was, and evaluating functions. I'm not really gonna go over like in this video, I'm not gonna go over specifically how to find domain and range of a function, because that's just a whole, yes, this chapter is about functions, but I don't want to, like I said, I don't want to make this video really, really long, because I feel like if I do, it's like I said, I don't want to make this video really long. So I'm going to do that. I'm going to do all of this in a different video. But yes, domain and range is usually, I think I believe that's the next section. And also, well, 3.1, which is this part here, is usually what, like how to like do all of this stuff and how to evaluate functions. Now, the last thing that I do want to go over as far as functions go is what is called the difference quotient. So I'm only going to do this for one type of function. So I'm going to do this for the quadratic function. So basically, if I have f of x equals x squared, I'm going to do f of x plus h minus f of x all over h. I don't want to do, like I said, I don't want to do what the other part is where you have to do like, what was it? You have to do like, because this is about functions, yes, but I'm not gonna do like domain and range yet. Like, we briefly went over it, but I'm not gonna do how to find domain and range because that's another topic about functions that I just don't want to put in this video. Because there's just a lot of functions okay? So, because there are like 6 or more different types of functions, and I really don't want to do that. So I'm going to go ahead and I think I'm going to go ahead and do this one, and then I'll end the video here. So, let's see. If I do, so f of x plus h, what that really is, we're just plugging in x plus h for x. So we're going to plug in x plus h. So we have x plus h, and then it's going to be quantity squared. So then what is this going to be? This is going to be x plus h times x plus h. And you can do FOIL method. So you do x times x, or you can even do box method like this, right? If it really helps. So you have x plus h, and then x plus h. So you have x squared, and then this is xh, this is xh, and then this is h squared, right? So then you're going to have x squared plus xh plus xh plus h squared, and then this is x squared plus 2xh plus h squared, right? So, we know that f of x plus h is x squared plus 2xh plus h squared. So we can plug that in for this part here. So we have x squared plus 2xh plus h squared. So that's what this part is here. And then we have minus, and then f of x is just literally this part here. So this is f of x, right? And we can put minus, so we can have minus x squared and then all over h, right? So if we simplify this, we have x squared minus x squared plus 2xh plus h squared all over h. Cancel out those terms, and then we have 2xh plus h squared all over h. And like I said, I know that we haven't done factoring in this video, but what you're going to do is you're going to just factor out. So you have h times the quantity 2x plus h all over h. Because when you do FOIL, or when you do distributive property, you will obviously get 2xh plus h squared, right? That's how you can check that you factored it correctly. Even though I know we didn't really do factoring in this video, but yeah. So So then this cancels out. So this cancels out. So then we have 2x plus h as our answer. And that is how you do f of x plus h minus f of x all over h for f of x equals x squared. Okay, guys? So, for those of you that do watch this video, I just thank you so much for watching. With all of this being said, guys, if you have any questions over this section, in the next video, what I'm gonna do is I'm gonna go over how to find the domain of different kind of functions. So like mostly domain and range, but I'm gonna go over what is called interval notation and how to like find the domain of any kind of function with a square root or even with with rational functions, because those two, and also, well, I don't want to do logarithmic because I feel like logarithmic is a little bit more tricky, but I will be doing with square roots as well as with rational functions. So that is going to be for the next video, but this whole video that I did was just an overview of functions, like, you know, basically what exactly is a function and how to evaluate functions. So with that being said, guys, thank you so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.